Thank you so much, Cindy. All right. Good afternoon to everyone. I'm back again, and today we will be working with our research data in Python, basically learning how to transform and organize all this data into structured data you can analyze. Without wasting any time, let us get into it. I will quickly share my screen. Great. So we're back again with our environment PyCharm, if you remember from the last time. And what we're gonna start with is before we analyze any data, we first need to understand the type of data we are working with. So we have structured data, which is obviously organized in a clear format, usually in rows, columns. I will open up the data I prepared just so we see what it looks like. So basically, this is the data here, very structured and usually in rows and columns and just makes clear sense. And then I also have some unstructured data, which I mean, it's very easy to understand it. Humans can read unstructured data easily, but computers struggle to read this because information is mixed up together in sentences rather than, neatly separated in commas. So one of the main goals is learning how to transform this unstructured data into structured data and then analyzing it. So this time I've prepared the script on my clipboard just so I don't have to code line by line. Otherwise, we'll be here for quite a while. The first thing we'll start with is working with the unstructured data, which is basically this file here. We have student research notes, and you have the learners here. Basically, a learner had 7 hours of sleep, participated in this activity, and it's just mixed up. The sentences are also different. So what we want to do now is we want to try and structure that data, try and place it in columns and rows so it's easy for our machines to analyze and read. Now, the script I have here, I'll just quickly jump it down. It's quite lengthy. It's about 81 lines of code. So this code takes the unstructured text from the Excel file that we have and converts it into structured tables that can be easily analyzed. So just to quickly explain what this code actually does, it loads the data sets. It uses pandas, so it's a library which we spoke about in our first webinar. It uses pandas that creates empty lists and extracts information. So the program then reads each research note line by line. So each research note one by one. It uses regular expressions, which is research. That's what we call it in Python. But when you import it, you just import RE, but it's called research. And it uses that to actually identify the patterns in the text, such as the study hours, uh, the exam scores, the attendance, the motivational levels, the gender, etc. And whatever values it finds, it stores it inside a dictionary. So in Python, we have what we call a dictionary, which we use to record data. And each completed record is then added to a list, which is later converted into the structured data that we are looking for. or rather structured data frames, as we would call them. And then finally, after that whole process is done, the data is cleaned, and then we're able to apply logic, and it's easy now for computers to actually read the data. So if I let me quickly hide this bar. So I've already imported my file here. So it's unstructured student research data, which is this one here. I just need to close it. You cannot manipulate a file that is open. Okay, I'll just minimize this a bit. All right, I'll run this file, and it doesn't take time. It takes a few seconds. Structured data set recreated successfully. So it creates the files in the same folder you have your script. So I've already, put it in the folder I want it to be extracted to. So this is the output the code has given us based on that data. I mean, what we have here, I think it's a bit better than how it was before, because with this, you can at least get some insights. You can do a bit of analysis, do a bit of checks, and see how accurate the information is. I see exam scores, sleep hours that were mentioned in their sentences. For those that mentioned whether they were male or female, it recorded that. For those that didn't, as we can see, the rows are empty. So I think with all these empty rows, we are also able to see that it's not always easy to take raw data, especially if it's in a format like the way it was, sentences, and extract it into structured data. But at least it gives us something. Well, in most cases, especially if you're working with research, you're not going to have this type of data. Most of the time, you will have actual proper data, which looks like this. And this is what we are actually going to work with. So this file has about 6,000 records. I got the data from Kaggle, so it's an open source platform accessible to everyone to extract data. So what we're going to do now is, before analyzing any data, we first need to load it. And the first thing we do in the data analysis is to load the data into Python. So basically, we can think of Python as a tool that helps us interact with the data instead of manually scrolling through all this and trying to find what we want to do. So I'll quickly go back to Visual Studio, and I'll open this blank script, clear my terminal, and I'll just, instead of typing everything, I'll be taking from my clipboard, and we can work with that. All right, so this is the first thing we want to do. We want to import our library pandas, and what we want to do is we want to load our data set. So this is the name of my file. I'm just going to add something here real quick. The path, actually. I'll copy this path and I'll paste it here. This will allow me to actually read the file in the place where it's located. There we go. It's not a copy, so I'll just remove that. Great. So this is my file over here. And I want to see what this file has. I want to show the first few rows of the file. So once again, I'll close the file and I will run this script. All right. So what this tells me is that Python is reading my file. It gives me sort of like an overview or just the few first rows of what the data is. I have the study hours, I have the attendance, I have the gender, I have the exam score. So all these things you see in your terminal. So basically, this is the first step for us to see what kind of data we're working with, what is in our file, or if the file is even being read by the whole program. So what we want to do now is we want to understand these data sets. So we need to understand what we actually have. So before analyzing the data, we need to have like a structure of the data set. What columns exist? What type of information is stored? What are the values or text? What are the numerical values, text-based, and or what is missing? So basically all the type of data. And we can do that as well. So the nice thing is, the nice thing I actually like is that many of these things you can do with just one line or two lines of code. You don't have to, overthink. So basically, here, this code here, it's just one line. All we're gonna do is show column names, and here we're gonna just show the data set information. It's nice to have these comments here to know what that line actually does. So when I run this code here, we can see now what it gives us. It gives us the columns, which are all the columns that are being listed here. So in this data set, we have 19 columns, as we can see. It gives us not null count. So basically, what columns are null or rather have nothing in them and what has something in them. So you can see it says not null. So basically, all the columns have data in them. We can see the number of records, 6,607 records in each column. And this is a pretty cool one. It tells you the data type. So basically, if you see something like int 64 or int 32, basically it's numeric, it's numbers in that column. If you see str, it's a string, meaning it's words. And there's many other data sets that are involved. We have like floats, we have booleans, but for now, we're just working with these two data sets. So it's a pretty cool thing to have. Now, what we're going to do is we need to we want to extract key information from this. Maybe in most, or rather some research projects, not every column is relevant to the question you are trying to answer. If we look through our file, we have 17 columns with so many rows, with 6,000 rows plus. And not everything we want to answer is relevant. Not all the columns are relevant to the questions we're actually trying to solve or questions we're actually trying to answer. For example, we may want to study student performance, so with that, we may only want to focus on rows like sleep hours. We may want to focus on rows like attendance here. We may want to focus on motivation or, maybe the exam score. So it's only specific rows. And so instead of working with the entire data set, we can only extract this information we need. This helps, reduce complexity when we do analysis. So with that section, I will take the block of code. And I've mentioned the columns I want to work with. So I've created a variable. This is my important data, which I want to work with. And I've added the columns I want to work with. Obviously, you can add as many as you want that are relevant to what you're actually trying to do. But here, let's work with this four. I'm going to run the script. And we have a new output down here. I only see the four columns which I've selected. which are the hours studied, the attendance, motivation, and the exam score. So I know that these four rows are being displayed. I can now work with them. So I can now focus on these rows while doing my analysis. And now I can organize the data into tables. So basically, once we extract all this key information, we can now organize them into like summary tables. For example, which motivational group performs best, or which students have the highest score, which category has the lowest score, and all those type of things. So with this data here, what I'm gonna do is I'm going to maybe print an average exam score by motivational level. So how will I do that? I'll just create a quick variable. I'll call it summary group by. Yes. Group by motivational level. Yes. And exam score. Motivational level, exam score. Print summary. Okay, red lines, you know what red lines mean? Meaning there's an error somewhere. Let me just take a look. Motivational score. Oh, okay. Okay, there we go. So what I'm doing here now is getting an average exam score by motivational level. So I'll run this so we see the latest results. And down here we have motivational levels. And we have high, we have low, and we have medium. So the highest score here, or the highest motivational level, is 67, the lowest is 66, medium also remains 67. So basically, this also works as relationships. I think I can do something on the relationships as well as we go down, so we understand how you can use this data that you've taken, or rather these important categories that you've selected, and see how they relate to each other. All right, so what we can do now is we can do basic analysis, for example, getting average score, getting the highest score, getting the lowest score. So all that can be done. Just take this block of code. All that can be done with just these three lines of code. So basically, highest score, lowest score, average score, one line each. And it gives you exactly that. We have the lowest score, which is the lowest exam score, which is 55, the highest, which is 101, and the average, which is 67. So sometimes you may not be sure if this is even accurate. So you can verify. You see 101 has me now because why is someone's score 101? So what I can do is I can just simply open the file and actually check it out for myself. By the way, I do trust the code. I'm just I'm just gonna do it for those who are wondering does someone have a score of 101. We can do max here. Okay. T1 to T6608. Yeah, so the max score is 101, as we can see here. For those that would want to verify the data, my max score is 101. So let's now go back to the relationships. So basically, as we know, a relationship, especially in the technical field, it means that a change, or rather that if one variable changes, one variable can change when another one changes. Yeah, I think I can put it that way. So for example, um, questions like, do students who study more hours achieve higher exam marks? Or does attendance affect performance? Does motivation levels influence results? So in all these questions, there's two columns that are being spoken to. And in Python, we have a module called core, which is for correlations, which basically measures how strong two variables move together. So think about like if study hours increase, then exam scores will also increase, something like that. And the correlation gives us a number between -1 and +1 over 1. So if it's closer to 1, meaning it's strong. If it's 0, meaning it's weak or there's no relationship. And if it's -1 and below, then that means it's a negative relationship, meaning there's basically no relationship. And I will quickly just put the block of code there, which is 2 lines as well. Correlation is our variable name. We take the 2 fields we want to compare, and we just print the correlation. And down here, we can see correlation score, which is 0.44. It's closer to 0, so that means the relationship is weak. It's not that strong. So that means studying hours does not really affect the exam score. That means in the data set, you'll probably find someone who slept less but has a high exam score. And you also find those who slept more and still have a high exam score. So basically that's how it works. And we can also we can do filtering, basically allowing us to isolate specific groups within the data sets. Maybe if you want students who are scoring above 80, that comes with conditional statements. So all you have to do is just throw in a conditional statement in your code and just select the column, have a greater than 80 condition, and just print that variable that you have going on. And it should give you the students that have 80 and above. Of course, 5 rows times 20 columns. It's not going to give you everything here. Otherwise, your terminal will look a mess. But it at least tells you there's more rows at the bottom, as we can see here. And these are just the basic analysis that you can do. Obviously, we can move into charts, but later on, there's some sort of charts that you can do. And once all the data is cleaned, organized, and analyzed, we often have to export it. For future work, you need to save it for future works, to share the findings, or to use it in, your data visualization tools. And after you've done all that you wanted to do, it's as easy as just having an export function which exports your data. So this can be tailored to specifically what you want to export. So you can choose what to take and what to leave in your data. And of course, in this case, it's CSV, especially if you work with models and these large languages and machine learnings, it reads CSV files better. So me running this script, it's gonna tell, okay, data set exported successfully. So I should see this file somewhere. Well, in my PyCharm root folder, which is here. It gives you an export. And as you can see, just to confirm, I want to see if I have all the rows. Okay, I still have 6,609 names. So that works. And yeah, basically, it's not just about coding, but I think it's about breaking down all the problems into small steps, identifying those patterns, applying the logic, organizing your information, and just using the system to solve our problems efficiently. We do not need to worry about the logic of the code so much. It's actually pretty easy because we can also use Gen AI tools to just generate these codes for us when we have the logic behind it and the prompt. So I think that's it from me for now. And yeah, I don't know if there's anyone who has any questions.
Thank you so much, Grady, for your demonstration. I definitely would like you to share the codes on our YouTube account, along with the recording of this demonstration, just for the viewers that want to try out this demonstration using the same code that you used, naturally with their own data sets, of course. I am curious to see the unstructured data. How does it look like exactly?
So basically, it's student notes. You have a bunch of sentences. It can be raw data, it can be paragraphs, it can be
On a
in
Word
all
document
sorts of
or
formats.
Excel?
So this one is on Excel, but it can be on a Word document. As I said, it can be in any format, Word, TXT file, or however you get it. The only thing is, however, if you want to export it to Python, you need to specify. Obviously, we work with Excel because it's much easier. Python reads Excel pretty well. So you could take your data from Word, put it into Excel, and work with it as is.
Right. Well,
Yeah, you can
that's all we had to offer today. Join us again next week on Wednesday at 12 o'clock with another dose of learning, a practical skill you can use for your research. Have a good day, everyone. Goodbye.